This is RD Sharma Solution, Class 12. We are taking chapter number 18, Maxima and Minima, exercises 18.5. Show that the height of the cylinder of maximum volume that can be inscribed in a sphere of radius r is 2r by root 3. Now, just imagine that you have a cylinder. It's a right circular cylinder and this goes inside the sphere. Imagine this as 3D because the sphere is 3D and the cylinder is also 3D inside. Now the radius of the sphere is already given. I am making the radius here and this is the radius, capital R, already given in the question. Now there will be a radius of the cylinder also. So let us imagine that the cylinder height and the radius, R is the radius and H is the height of the cylinder. Now this one is the radius I am talking about and this is small r that we have just imagined, and from here to here it's H, and it is quite evident from the diagram that this distance from the center to the top is simply H by 2. Now just concentrate on this triangle. This is a right angle triangle. We have HR as the base in the altitude, R as the hypotenuse. From here we can apply the Pythagoras theorem, and that Pythagoras theorem is going to give you as the hypotenuse square is equal to the base square plus the height square or the altitude square. Here we have r square equals to small r square plus h square by 4. Now we have got a relationship. You can have a relationship because capital R is already given. Small r and small h we have imagined by ourselves. So this one, h will give you twice of under root r square minus r square. One is the capital one, the other one is the small one. So volume will be, what will be the volume, because we are talking about maximum volume, pi r square h. We call it as V. V is pi r square h. Now why have we done this? Why we are squaring it? Because this doesn't affect our final solution. Because V, whatever the value on the both sides is, if you square them, then also the things remain the same, and because of the next step what we are performing here. So this volume I have squared and I'm calling this V square. We cannot take V square every time. So this pi square r raised 4 h square, in place of h square you can replace this by 4 capital R square minus r square. So I'm replacing it right now. I've got it from the equation number 1 only. And next thing which comes from here, as we said that this V or whatever is on the right hand side, we square it, the things doesn't change. That is, the dz by dr is simply equal to dv by dr if we would have taken it earlier. So this is dz by dr. And when you differentiate it, and I know that differentiation is quite known to you, I'm writing the differentiation right now, and most of the things, better is to multiply this r raised 4 inside. Otherwise you have to go for the product rule. Multiplying inside will simply ease your way of doing the differentiation. Now this is the differentiation value or differentiated value which I am talking about, and I am going to differentiate and equate it to 0. So when you differentiate, you put it to 0. Now you will get the critical point, which is actually equal to the r what is being asked in the question, small r, capital R and h. Capital R is already given. So when you equate it and just take r cube outside, inside you have 4r square minus 6r to the power 2 equals to 0. R cube cannot be 0, the radius cannot be 0. So 4r square should be equal to 6r square. One is capital, one is r squared. Now you have a relationship between small r and capital R here. Small r square is 4 capital R square by 6. So this under root will give you twice r, and this is going to be under root 6. Let it be like that. But remember, what was r square? It was 4r square by 6 into small r square by 4, like that. Now we already got r equals to 2r by under root 6. Let us call it as equation number 2. We have already differentiated, equated it to 0. Next one is to find out the double differentiation. But before that, let us find out the height. The whole idea is to find out the height. In the question also height. So h is twice of under root capital R square minus small r square. Small r is already in terms of capital R, so just replace this 4r square by 6 as I indicated earlier. This height you are going to get as 2 capital R by under root 3. Now this actually solves the question, but the scenario here doesn't stop, because you have to show the examiner that this volume is actually maximum. So this d2z by dr square has to be done, and in any way you have to show that it is going to be negative, because negative corresponds to maximum value, positive corresponds to the minimum value. So when we differentiated, double differentiated, and now you have to do certain replacements that you will do, I am quite sure. And when you do all this, you are going to get certain value with certain sign. And we are not interested in the value or the expression. We are simply interested in the sign. So replace this small r by 2 capital R by under root 6. Final value is 4 pi r square minus 16 by r raised 4 by 3. Now these all are positive, these all are positive, negative is already there. So the result is a negative, which signifies or indicates that we are talking about the maximum volume with the height as 2 capital R by under root 3. So height already computed, but we have to strengthen our height computation by saying that this is the maximum volume. So this is the step-by-step discussion of what we have done right now. And once you have made this expression along with the diagram, because I showed it with the diagram, when you are aware of this expression, all things are a piece of cake for you. A rectangle is inscribed in a semicircle of radius small r with one of its sides on a diameter of semicircle. Find the dimension of the rectangle so that its area is maximum. Find also the area. Now this rectangle is inside the semicircle. Let us make the semicircle, and this is the semicircle. I am making a rectangle. Rectangle is that shape which have opposite sides equal, and square is the special form of rectangle where all sides are equal. We're talking about rectangle here. It is inside the semicircle. So this hole is twice r. So this rectangle could have been made like this because it is already given. The side is on the semicircle, and we need the maximum area. That is why we touch the corner to the semicircle, and that will give us a relationship. Let us say the x is the base and y is the height, or you can call it as x as the length, y is the breadth, which is popular when we deal with rectangle. Now we need the area to be maximum. But before that, we need certain relationship, because small r is already given. X and y we have imagined by ourselves. So we need a proper relationship between this r and y and y and r. Small r and the x and y which we have imagined. Okay, take this rectangle and this part which is the triangle, which I actually trimmed out of it. And r is the radius, which is actually the hypotenuse. Y and x by 2 are two supporting sides with 90-degree angle between them. Now you can apply the Pythagoras theorem here. That is, the r square is equal to y square by plus x by 2 whole square, which is x square by 4. So this equation is the key to solve this question. Now x square is this one. See, we are going to use it because x square we found out from this equation only. Second step is we need the area. We have to show that area is maximum. What is area? Area of a rectangle is the length into breadth. In this case, since we have imagined x and y, x into y is the area. Now when we deal with this x and y, we have to convert x into y or y into x. At least one should be in terms of r so that we can actually differentiate. It should be dA by dx or dA by dy. That kind of thing we are talking about. Now square both the sides. When you square both the sides, as I told you, squaring won't affect the result. So I've squared it just because we already have x square as 4 into r square minus y square. So in order to use it, I squared it and called the a square as z. It won't affect. Now y square and x square, because x square is already there, y square is there. So we have replaced x square by 4 into r square minus y square. This is z. Now second, or you can say the next step is placing this differentiation equals to 0. For that we need differentiation, that is we need to differentiate this. And once we want to differentiate it, what do we get? See, this is 8y square minus 16y cube, and third step or the continuity step is to have a 0 on the right hand side. So 8y square minus 16y cube is equal to 0. That means y into 8r square minus 16y square equals to 0. Y cannot be 0, so 8r square has to be equal to 16y square. From here we get y square is equal to 8r square by 16. So 8 to the 16 it goes. It's simply r by root 2. So we have the y value, and since we have the y value, we can use this y value, place it in the equation number 1 in order to get the value which is x, because x and y are guessed by us or let by us. So we need the proper value of them in terms of the given value, which is small r. So now I am replacing y as r by root 2 in the equation number 1 in order to get the value of x as well, because the question is asking about the dimension, and dimension of the rectangle is x and y in terms of r is admissible only in this question. The fifth step which we are going to do is d2z by dy square. This is a completion step because the question is already being solved, but we need the double differentiation in order to show that the area which we are going to get will be maximum, and we need to find out the area also, so there will be next step also. But here the double differentiation, when we actually do it, and that is your responsibility, differentiation is quite easier for you. Now just replace this y by r by root 2 in the differentiation value which we got, and the final value which we get is a negative. This is the final value you will get when you double differentiate. So the negative value corresponds to maximum of whichever entity, in this case area, we have taken. So x is r root 2, y is r by root 2, and the sixth step and the final step is to find out the area. What is the area? Area is x into y. Multiply them, you can see visually root 2 gets cancelled. It's simply r into r, which is r square. So area of this shape, which is rectangle, is r square. So whichever things we have discussed, it's been given here, and you can follow this and write exactly similar to like this or in the terms which is written here. So you can take the reference also. Prove that the conical tent of given capacity will require the least amount of canvas when the height is under root 2 times the radius of the base. So simply we need to find out height. Prove h is equal to under root 2r. So this is a conical tent I am making. Just imagine you are wearing a hat on your birthday or eating an ice cream, cone ice cream. So this is an inverted cone right now. So this is the radius. From here to here we are saying that this is the height, and we need one more term here, which is the slant height, because the question is asking about the canvas, so we need the surface area. So first thing first is the expression, because everything comes with an expression. If you are able to find out the expression in the sentence type question or word questions, then the next thing can be done. Capacity only means the volume. Here capacity corresponds to volume. The surface area of cone is, you already know, pi into r into L. What is the L? L is the slant height, and this slant height is simply because this is a right circular cone, the L will be equal to under root h square plus r square. So pi into r into L, in place of L just replace it by the Pythagoras theorem value, which is under root r square plus h square. So I'm writing it directly. You already know it in your previous classes because we have already done mensuration quite a lot. Next thing comes in this question is the capacity. Capacity is the volume. Volume is 1 by 3 pi r square h. When we take the cone, what is h? The h in terms of v, it's 3v by pi r square. Now we already have h. The surface area, because we need to tell about the least amount of canvas. So surface area has to be maximum or minimum. So surface area is pi into r, and under root r square plus h square. In place of h square, replace it by 3v by pi r square. So this is the final result which we are getting when we replace it. If there is slight difference or mistake, I beg your pardon, but I'm writing because this is simply the replacement of the values we got. And the whole idea is that if you remember this surface area and the volume, you're going to get through it. So I'm making a relationship between the surface area. So this whole, I'll just change this v raised 6 because I don't think it will come. It will be square only. So I'll just replace it. But the next step has to be this s. Now this ds by dr has to be taken because the differentiation has to be done. The final differentiation value I'm writing here, and there will be some effort which you are going to put in for differentiating, and I'm writing the final value just for your reference. This is the final value when we differentiate it, and it will take because you have to follow either the product rule or the quotient rule. So there will be two terms here in the final differentiation. Once you differentiated it and just match it, okay, this v to the power 6 we'll just replace it by v square. It will not come. And when we equate it to 0, because the next step will be equating the differentiation to 0. When you equate it to 0, the final relationship will be 2 pi square r raised 6 is 9v raised. I am still skeptical about this v6. I'll just revisit this. See, all this will give you a relationship between your r and v. And v is already there with us. 1 by 3 pi r square is already there. In place of this v, I am replacing this v raised 6, which is a slight mistake which I committed. I'll make it as v square. V square is 1 by 3 pi r square h whole square. It will be 1 by 9 pi square r raised 4 h square. And this square, as I said, I'm replacing it. So we are going to get a relationship. All those simplification and cancellation you can really do and understand here. But the whole idea is to get, because we are interested in only the height should be equal to under root 2 times the radius of the base. So when we see here, there are cancellations which you see, and h is equal to under root 2 r will come. And this is the actually end of the question, I should say. But we have already proved it. But we are not going to stop here. You tell me why? Because in Maxima and Minima, you have to show that you are actually getting maximum and minima, and that is only possible when we double differentiate it. So you need to do some more effort here. That is, the ds by dr has to be d2s by dr square. So the whole expression which I wrote, because I just changed this minus to equal. So d2s by dr square, and this is again an exercise for you. When you do it, it is going to come as positive. Okay. So because h equals to under root 2r is already done, this is just a completion step, which is the positive value should come so that least amount of canvas can be there. So h equals to under root 2r is where you are going to stop. And when we proved it, because we don't have to find any dimension of the area or anything. So this whole is the steps being followed here. And when we followed this diagram, because we started with the diagram, remember, and now we got this whole v raised 6 is a slight misprint that you can replace it by v square. So all these needs to be remembered from your earlier classes. And this question we are going to take in the next discussion. Till then, thank you so much. Take care of yourself.